Alright, the graph of f of x equal to x squared minus 3x minus 3 is to be drawn for the values of x between minus 2 and 5. First, compute the corresponding values of f of x for each of these values. Next, we plot these pairs of values on our axis, which is ready being prepared at the required scale. Next, we draw a smooth curve through our points. There, and we have our curve, which we call a parabola, which is the graph of f of x equal to x squared minus 3x minus 3. Good practice says that we must put a title and a scale on our graph. So we do that now. And we put on our scale in a place that is out of the way. Good. Now we'll answer the questions on the next page, which we will show here. We want to first draw the line of symmetry of the graph and write down the equation of the line of symmetry. Well, this looks like our line of symmetry. It's the line that divides the graph into two equal parts. Now let me use a better and our line of symmetry has an equation x equal to 1.5. So we put that in our x equal to 1.5. Next task is to find the value of f of x at x equal to 2.5. So we find x equal to 2.5, and then we drop a vertical line until we meet our graph, and then take a horizontal line across to read off what was the value of f of x at that point. And on my graph, I have f of x equal to minus 4. People will get different values according to their graph. Find the values of x for which f of x is equal to 0. Well, here is where f of x is 0 on our graph. This looks like 3.75, and this is minus 0.8. Find the minimum value of f of x. Well, this is our minimum value, and it looks like about 5.2. This is our minimum value here. And this f of x equals 5.2. Minus 5.2. And the value of x of which f of x is a minimum, we know it has to be at our line of symmetry. Now, the solution of x squared minus 3x minus 3 equals 4. Remember, we're using the graph. So we draw a horizontal line at x equal to 4. F of x equal to 4. And then see where it intersects our graph. So we see it intersects here and here. And we read off our values. At this point, this looks like about minus 1.6. And here it looks like about 4.5. So we say x equal minus 1.6, x equal to 4.5. And the interval on the domain for which f of x is less than minus 3. So here is x for which f of x is less than minus 3. So we are concerned with here. And we see that in between these two values, x equals 0 and x equals 3, the graph is below this line, f of x equal to minus 3. So our interval is x greater than 0, less than minus 3. Less than 3.